Yeah, are you ready? Yeah.
Hello, my name is Louis Latour. I'm a developer here at FHIR, and today I have the pleasure to present James Agnew for the talk Introduction to HAPI Server. Floor is yours.
Awesome, thank you. All right, oh, there we go. Ooh, that's nice and loud. So good afternoon. Welcome, everybody. Welcome back to DevDays. This is super exciting to all be back together in Amsterdam. I love it. We're going to talk about HAPI. I keep wanting to say this morning because it's morning for me back home, but it's not morning at all. It's afternoon here. I'm going to try and change things up a little bit. We've been doing this intro to HAPI since the very first DevDays, actually. And we've usually done it as just sort of here's the real basics about the library. We get into some real basic use cases, but I found increasingly people come who've already played with the library a bit and maybe don't want the absolute intro. So I'm going to try changing it up by, instead of sort of really giving you any details about the basics, I'm going to try and give a whirlwind tour to everything that is HAPI. And we'll see if that format works well. And I would love to hear afterwards if you think that's useful or not, but let's give her a shot. So a quick introduction to myself. I'm James. I have been leading the HAPI project since roughly 2005. Didn't originally start it, but I joined a couple of years in. HAPI originally was an open source implementation of the HL7 version 2 standard. And we spent many years as really one of the few sort of big open source projects in healthcare. There are others, of course. The Vista project is vastly larger than we are, but we were one of the few that was really focused just on healthcare applications in the early days of open source in this world. And I think we've done some cool things over the years. By day, I'm with a company called Smile CDR or Smile Digital Health, and have been leading the HAPI project for a good while. This is my sidekick Dharma, who I realize is blocked by. There we go. Maybe that's better. Cool. All right. So quickly, I'd love to get to know you guys a tiny bit. How many people here are brand new to FHIR? Show of hands. Anyone at all? Oh, nobody. All right. Lots of experts. I love it. Who's new to HAPI? Okay. A few. I love it. Who's using HAPI today? All right. That's what I figured. Lots and lots of people who probably don't need to know how to work a parser. It seems to be how this goes. So as I say, we've been at this a good long time doing open source for healthcare. I am a passionate believer in the power of open source and to transform technology, transform community, to ultimately sort of bring about good change and help people do cool things. I've loved open source for decades now, and I just think it's a really neat movement. And I think we're doing cool stuff together. So glad to see lots of people here are interested in the library, lots of people interested in sort of getting started with it. We do have two sister projects, the HAPI HL7 version 2 library, which I've got a link up there, and then HAPI, which is the library we're going to talk about today. Just to give you guys a little sense of where the library comes from, just because I always think this is interesting. We started the HL7 version 2 parser about 20 years ago at a hospital in Toronto, where I'm based. The project we were trying to solve in those days was sharing health records across two hospitals. Building what today you would call a health information exchange. But of course, 20 years ago, there was no such thing as an HIE. All we had was this idea that there were doctors cross-appointed in two hospitals. They often had patients who sort of wandered between the two hospitals to get tests done. And because they had different EHRs, different EMRs in those two hospitals, the doctors had no way of accessing test records from one institution to the other. So we thought, let's build a little portal that would aggregate the data from two institutions and show it in a single view. And this is that screenshot there, which is perhaps hard to see in the back, is a mock-up of that system that we built 20 years ago. That for anyone who's been developing a long time, that's Internet Explorer 5. So that gives you a sense of the problems we had trying to build that system. One of the things we realized early on is that there was no free software to do HL7 version 2 interfacing. And in those days, that was the only way you could get data in and out of EMRs was HL7 version 2. So we started an open source library, and the rest is history. FHIR came along. We thought, this looks cool. Let's do a FHIR library. And turned out it was cool, I guess. So HAPI, right from the beginning, as I say, we're big fans of open source. We have licensed the library under the Apache 2 license, which for anyone who's not a big open source nerd, perhaps you've at least heard of Apache 2. Apache 2 is a very business-friendly license. And this is probably the most important thing about HAPI-FHIR. We believe strongly in people using the library, using it in their own products, developing things, adding things to it. The neat thing about Apache 2, as compared to sort of some of the more restrictive open source licenses, there are no royalties, there's no requirements, there's no, like, you don't need to tell us if you're going to use the library. You certainly don't need to tell us or pay us or anything like that. If you're going to build your own products, you're welcome to sell things that are built on top of HAPI. And we truly believe that, like, we love it. This is, as everything in the FHIR community, we are big believers in open source, open standards, and all that good stuff. So if any of you are thinking of developing your own systems built on HAPI and going out and making some money, we'd love to hear about it, but you don't even have to tell us about it. And we know lots of people don't. That's totally cool. Design goal number 2 is we try to be super flexible. We've been inspired really quite a bit by a framework called Spring. To the Java developers in the room, you probably either love Spring or hate it. Everybody falls into one of those two camps. Like nobody's so on Spring, I find. I personally love it. And if you don't, that's cool. The thing I love about Spring is it's this giant collection of little utilities that all solve individual problems, all play really well together, but aren't particularly coupled to each other. So if you only need one of those modules, you only have to use one of those modules. The classic example in Spring is you can use Spring security independent of their REST framework, or you can use their REST framework independent of the security framework. And the two really play well if you want to do both of those things. HAPI, we've tried to do the exact same way. So with HAPI, if you just need a parser, just use the parser. If you just need a validator, you just use that. But if you need both of those things in a server and a client, we've got all those things and they all play well together. So we've tried along the years to stick to that same ethos that I think Spring has done really well. We've tried to be inspired there. The other bit that I have to give a shout out to, because we've been inspired a ton over the years, is the FHIRly.net SDK. Ewout and I, for probably 10 years now, we try and get together at least once a year to compare notes. And while the two libraries are not nearly identical, I like to think that we've stolen a bunch of great ideas from Ewout, and I know he's stolen a bunch of great ideas from us as well. So there's been some good sort of synergy there across the community with the different library authors as well. This, before we get into anything more on the actual details of the library, I love this slide because this is for anyone who doesn't recognize it, that's a Google Analytics map of people accessing. What this actually is people accessing our developer documentation. And to me, this is just a really nice sort of little microcosm of FHIR use around the world. I try and pull one of these maps every year just to sort of compare where are they growing, where are they shrinking. I mean, not that they ever shrink, but relatively they do, because there's always new cities sort of popping up on the map. And I mean, to me, this is this is a great visualization of the power of the FHIR community. You can see we are truly a global force. There's lots of gaps in there. I think we've still got lots of work to do, because really there should be circles everywhere, but it's kind of neat to see it visualized that way, I've always thought. So into the meat of the library. HAPI-FHIR, of course, we're now at, what are we at? 36 releases, I think, from the start, something like that. Our most recent release, HAPI-FHIR 6.6.0, adds for the first time final support for FHIR R5, which is, of course, the current release of the FHIR standard. I like this little matrix here just to sort of highlight the fact that the HAPI library and the FHIR standard are versioned independently. And this is important. People sort of assume that, I have to use HAPI 5 if I want to use FHIR R5. Those two numbers have nothing to do with each other. And what's really neat about HAPI, actually, and is from the start, we've tried to design a framework that allows you to support multiple versions of FHIR at the same time. This hasn't been a thing traditionally a lot of people have done, but I have this feeling it's going to start being really popular in the next while with the release of R5. I think the current R5 release, this is probably the first time that we've got a new release of FHIR, and there are just massive numbers of existing production software out there on a previous release of FHIR. Nobody wants to throw that investment away, but people are going to start wanting to think about how do we add support for R5 as well. With HAPI, you can do that. You can easily sort of bring in support for multiple versions within a single application. A couple of links, and I'm going to walk you through some code as introduction over the next few slides. All of the code that I'm going to show you is at this repository here. It's a repository we've been sort of jointly maintaining with a couple of other community members for years now. We call it FHIR starters. And effectively in there is a bunch of starter projects for Java. There's some .NET starter projects. There's an iOS starter project in there. There's some Postman collections. So we've been sort of trying to keep this repo as a nice starter place to learn about various libraries and various frameworks for working with FHIR. The other link, of course, I'll direct you to is our website, happyfire.io. And the reason I have this up here is to draw your attention to these little links that you'll find in our documentation that say get started with a little lightning bolt. If you want to get started with any of the things that we're going to talk about today, look for those get started links. They will take you right to a starter project for the specific topic you're interested in. So if you want to play with clients, if you want to build plain servers or JPA servers, and I'll tell you what that means in just a second, but if you want to start playing with those things, there are starter projects for all of them, and they're all linked to from the Get Started link on the website. And really, I mean, if you wanted to leave now, that's the most important thing I have to say. So there we go. You can tune the rest of this out if you want, because you know where the starter project is. This is our diagram of the modules of the library. We've got obviously lots and lots of stuff in here. I don't have nearly time to do any of it justice, but we are going to talk through a couple of things. We're going to talk this morning about, or this afternoon, I'll get that right eventually, parsers, serializers, clients, servers, and validation. That's the things I want to cover before the end of today, and I probably won't have time, but let's try. First off, this is a simple example. I'm not going to spend almost any time talking about it. All I want to say here is that working with FHIR objects in Java is really easy. If you want to work with a patient resource, there's a class called patient, as you would expect. There's methods for adding names and fetching things and working with coded fields and various data types that are in there. The one thing that I will point out in here is we've been really inspired by this sort of what we call fluent API design. Everything is designed to chain together. I find it makes for really readable code. You may or may not agree with that, but I quite like it. I think you can sort of look through this and exactly see what's going on. It's pretty obvious how all that stuff works, I find. Data types, no different. FHIR defines a whole collection of really rich data types, of course, and we have created wrapper classes for all of those. People often ask, why do you need wrapper classes? Java's got those primitive data types already. The answer to that, if you're curious, is because FHIR's got extensions, and those extensions can go basically anywhere in resources, almost anywhere. And certainly anywhere includes data types. So you can put an extension right on your date time type, for example, which is why we don't just use a Java date object. Getting started with the library, the first class that you will almost ever have to interact with is this thing called the HAPI context, or the FHIR context class. This is your gateway into everything else HAPI. You can ask it for parsers, you can ask it for clients, you can use it to create validators, FHIR path executors, servers use it, various things all take advantage of your FHIR context object. I always want to stress the biggest anti-pattern in HAPI is creating multiple FHIR contexts. You should always be creating one and reusing it across the lifetime of your application. It's designed to be done that way. It doesn't leak memory or anything like that. So it's very safe to keep one, put it in a static variable or something like that. I don't know. I'll say it again. Don't create lots of FHIR contexts. It's a performance problem I've seen people have. Using the parser is really simple. That's probably also hard to read, but this is a simple example. I go and ask for a FHIR context. I ask my context for a parser, and you can configure the parser if you want. The parser's got all kinds of methods for parsing things, for serializing things. We sort of overload the concept of parsing and serializing into a single object called the iParser. In this case, I'm going to serialize a resource that I've created, and what comes out is this. So I've got a nice, pretty printed, formatted version of the resource that I created above. So nice, simple example. I will also, I guess I should have said this before, I'll also say any code samples I'm showing you today, you'll notice they have these weird file names, example 04. The reason I do that is you can find all of these examples in that FHIR starter repo. So if you want to try running this yourself, you'll find it in that repository, and you can run it. They're all designed to be run. So let's talk quickly about the client, how that works. Clients are really easy. As you can see here, once again, I ask for a context. To give that context a base URL for a server, and it gives me back a client. And out of that client, I could do all kinds of things. In this example, I'm calling a .create on it, and I'm sending that a resource. Client operations always end with .execute. So you've always got a chain of methods. This is, if you're doing read or search or transaction, whatever FHIR operation you're doing, you chain a few methods together, and then you call .execute, and then it happens. And if you want to know sort of how you do any of these things, I'm not going to show them all to you. I've got one simple example of create here, but if you want to do how to do a search or a patch or any fancy FHIR thing you want to do, there is examples of all of that up in our documentation on our website. So lots of good examples there. The one question, if you haven't worked with a client before, that you may be asking yourself is, what about authentication? Of course, I've just passed in a server URL and I've passed in no authentication. I feel like that's an obvious thing to wonder. We will talk about that in just a moment when we get to interceptors. And I guess the last thing to mention here is the client operations will almost always return what's called a method outcome. The method outcome contains all kinds of things. You can get at the headers you got back from the server. If the server responded with an operation outcome or a resource body, you can get access to that from the method outcome. If there was a location header with an ID for the resource that we just created, that will come back. And in that case, that is what we've got. So this is an example of logging that so that we see it. Another thing to draw your attention to in HAPI/FHIR, we've got a rich hierarchy of exceptions. They all extend from a class called base server response exception. There's something like 25 exception classes that all extend from base server response exception. And the reason we do that is we've got one to correspond to each of the HTTP status codes that are commonly used in the FHIR spec. So for example, I've got two up here, resource not found, which of course corresponds to your classic HTTP 404. You might want to catch that if you're doing a FHIR read, because that way you can know, like, did we actually get something back? If the server is broken and it's returning HTTP 500s, then you're going to want to catch the internal error exception. And there's a whole bunch more of them. As I say here, if you go on our website, look up our Java docs and open up the API documentation for base server response exception, you will find a link back to basically a big list that has all of the different exceptions that we include in the library. So that's clients. Let's talk about servers for a second. This is probably the most fun part, I think, of HAPI/FHIR, is working with servers. I will say, I mean, there are lots of people out there that are, working directly with model classes and doing parser and serializing stuff and building clients. Lots of people do that stuff with HAPI, but honestly, the biggest use case for sure is building servers. I think that sort of makes sense. I mean, Java itself is predominantly a language that gets used for servers. I mean, things like Minecraft aside, most of the time, if you're using Java, it's probably because you're building servers. So the server framework in HAPI/FHIR tends to be our most popular bit. We've actually got two server frameworks as a part of the library. We call them the plain server and the JPA server. Actually, we've got three. Those three are the plain, the JPA, and the JAX-RS. To tell the difference between the three of them, first off, the plain server is what we call a facade server. The idea with a plain server is you are providing storage logic, and HAPI/FHIR is taking care of everything except for the storage part of it. The best way to explain why you'd want to do that is actually to talk about the original use case for HAPI/FHIR, the library. When we created this library, I was working at that point in a hospital. We had a data warehouse, as many hospitals do. That data warehouse had been around for 20 years. So of course it had nothing to do with FHIR because it predated FHIR by a long time. And we'd built up this really fancy, we thought they were fancy, set of SOAP-based web services to get data out of this this data warehouse. To anyone in the room who's ever used SOAP, you know why we were unhappy about that decision. SOAP was an awful protocol. We looked at FHIR and thought to ourselves, this is so much better than the SOAP nonsense we've been using for the last few years. And this was like literally DST1, the first pre-release of FHIR. We thought, even though this is this brand new thing that's probably going to break a whole lot over the next few years, it's still way better than our existing APIs. So let's try and build an interface on top of our data warehouse using FHIR. And so we built HAPI/FHIR to do that. That's how we built this plain server. And the idea was we wrote some database code. We as a user of our own library wrote some database code that would go into our data warehouse, fetch data that was responding to whatever queries were coming. And the framework takes care of everything else. It parses URLs, it serializes things automatically, it handles all the content negotiation, all the things that you need to do in order to be a FHIR server. All of that's done. the server just handles pulling data, basically pulling data out of the database and providing it to the framework, where the framework takes it from there. I will tell you that was from day one. Every one of our users at Data Warehouse fell in love with it. Like we heard nonstop from everyone that was using it. This is so much better. We love this FHIR standard. And that was kind of the day that I realized FHIR was going to be a big thing. So that's the plain server. The JPA server, unlike the plain server, is, we always call it a FHIR server in a box. The idea is, if you have got an existing data model, you want the plain server. If you don't have an existing database, for example, you don't have a structure you're trying to fill in, then the JPA server does all of that for you. It's got its own database schema. It manages the tables. It manages, inserting data and pulling it out. You can treat it as a full application that is a fully blown sort of FHIR server. It is quite comprehensive, actually. I will mention quickly, we've also got this third server, the JAX-RS server. It's more like the plain server. If you've ever used the JAX-RS framework, it's kind of a neat option. I will say, I'm not going to talk about it at all today. It's really only intended for people who are using JAX-RS already and want something that integrates well with that framework. It was a community contribution, which is kind of neat. We had a very generous group from AgFA Health actually contributed that to HAPI FHIR a few years ago. So plain server, the way plain server works is entirely about creating these things called resource providers. Resource providers are really basic classes. They implement one interface called iResourceProvider. In that class, you're going to create a bunch of annotated methods. I'll show you an example in just a second. But effectively, what you're doing is you're writing classes that are annotated to be a create or an update or a read. In those methods, you write your storage logic. HAPI will scan those classes. We'll turn that into an HTTP server. We'll deal with everything else. It does it all quite nicely. So this is an example of what one of those classes will look like. As you can see, we've got @read, @create, @search. And of course, you would go in, you would fill in all of that logic to add whatever your storage, your store, your retrieve, your fetch, your search, all that stuff. Once again, I don't have time to go through all these annotations and what they all mean and all of that, but it doesn't matter. The documentation, I like to think, is pretty good. There are examples of all of this, and there is, in fact, a really good starter project that will get you started with plain servers if that's a thing you want to do. Only other thing I'll draw your attention to, if you're just getting started with plain servers, there is a class that is a part of our repository called the HashMap Resource Provider. HashMap Resource Provider is an example resource provider that stores all of its data in a hash map, as you might guess by its name. Pure in-memory server. You obviously would never sort of use this for production purposes because it's nothing but in-memory. It'll lose data as soon as your server restarts. But it's great for testing, and it's even better for learning. If you want to learn how to do everything you could ever do in a resource provider, there is examples of all of it in the HashMap Resource Provider. It sort of, it shows you how to do versioning, how to handle patches, like all these fancy things you'd want to do are all in there. So kind of a neat little tool. The JPA server, on the other hand, is the full server in a box. The way it works is as follows. It actually builds on top of the plain server. It includes a bunch of these resource providers, but with the JPA server, you don't write the resource providers. We have supplied them. So we supply a resource provider for all 150 FHIR resources. I think it's like 190 now. We've got them for every version. We're built on top of a framework called JPA. If you're not familiar with JPA, it stands for the Java Persistence Architecture. It's most commonly known to Java developers as the Hibernate framework. The idea with Hibernate is you can use it against a database of your choosing. Hibernate supports something like 25 different database technologies. We've got 3 that we officially support for production use. They are MySQL, or not MySQL, MS SQL, like SQL Server, Oracle DB, and Postgres. Those are the 3 databases that we support for production use. We also support for non-production use the H2 Pure Java database, which is kind of a neat testing database as well. I will say there are people using HAPI FHIR on all kinds of other databases as well that are supported by Hibernate. Nothing wrong with that. Lots of people have had good success on other technologies. The only one I would kind of caution against, truthfully, is MySQL, just because we found performance has been fairly bad with MySQL specifically. Not a hit against MySQL, just the way that we use it specifically in our schemas doesn't tend to perform so well with that database. So there we go. Using the JPA server is kind of a neat experience, I find. I'll draw attention to the starter project for this. And once again, there's a link to that on the Get Started link in our website. I'll say the JPA server starter is it's the one project that works differently from everything else in HAPI-FHIR. Everything else in HAPI is a software library and purely a software library. So the idea is you would include our jar files in your Gradle file or your Maven POM file, your Ant file or whatever. You'd pull them in and you would write an application around it. The starter project, on the other hand, is an application. It's not a library. So the idea with the starter project is if you want to use the JPA server, go onto GitHub, take out the starter project and either make a copy of it or fork it or, do whatever you want, but you actually use that as your start. You don't have to, but that's how most people use the starter project. There's lots of good stuff in there. If you go into that repository, there's pre-built Docker images of it. There's all kinds of configuration. It's built on Spring Boot. So there's a giant YAML file with 1,000 config options. It's good stuff. There is a lot in there. I'm not nearly gonna, of course, have time to talk about it, but I will draw your attention to a couple of neat features in there. There's support for subscriptions, support for bulk import export, partitioning, which is most commonly used for multi-tenancy. That's a fairly recent feature we added that people tend to like. MDM capabilities. So if you want to do master data management or EMPI technology, there's some really good stuff in HAPI for that. There is a full-blown terminology server and a ton more. So it is a really, really full-featured FHIR server. We see people doing lots of neat stuff with it, and certainly lots of good production sort of use of it these days, which I always think is fun. Quickly, I'm going to talk about interceptors. Interceptors are a mechanism that you can use in HAPI-FHIR to add your own processing to some part of what we call our request processing pipeline. That's kind of a wordy thing. And what I mean by that is if you think about a server responding to a REST request and all the things the server needs to do, like a server is going to receive an HTTP URL, it's going to parse it, it's going to look at the verb. If there's a body, like a request body, it's going to parse that as well. It's going to figure out what FHIR operation are we actually supporting. It's going to call your resource providers. Eventually, you're going to return some data. It's going to serialize that. It's going to send it back to the client, or maybe you've thrown an exception. It's going to handle that. All of those steps are what we call the request processing pipeline. And you can write with our Interceptor framework these things that we call hook methods that inject logic into any step along that request processing pipeline. Super neat framework, documented extensively on our website, so I won't go into too much about it. The only other bit of vocabulary I'll mention here is we call these steps in our request processing pipeline point cuts. And anyone who's ever done aspect-oriented programming will recognize that term. I guess we stole it. It's not even stolen. We're kind of using it correctly according to AOP. Basically, a point cut is a spot in the pipeline, and you can add your hook methods to a specific point cut. That's the way that works with interceptors. This is a diagram. I know you probably can't read it from the back, and I'm not going to try. This is taken right from our server documentation on our website. What I'm talking about here is all of the steps that I just described around the request processing pipeline. And this sort of shows you all of the different point cuts that you might add your own processing logic to around that loop. Don't worry about trying to read this. As I say, you can go to client point cuts and server point cuts in our documentation, and you will learn about all the point cuts, and you'll see these nice diagrams that walk you through the various point cuts that are there. We do have a bunch of built-in interceptors. You can also absolutely write your own. The framework is certainly designed for you to come up with your own, but I will mention a couple. The logging interceptor is often very popular. It's used for, of course, logging your requests and your responses. CORS, if you're building JavaScript apps, is always a useful thing. So the CORS interceptor allows you to do that. We've got the request validating and response validating interceptors, which are used to validate payloads. The response highlighter interceptor, which gives you nice rendered HTML for response if you want that. And a very popular one recently, the Open API interceptor, which automatically adds support for Swagger and Swagger UI on top of your servers. That's a popular one. This is probably about 1/5 of the built-in interceptors in the library. So once again, I'll draw your attention to the docs, built-in server interceptors. There's a page there that goes through all of the rest of them. Quickly, and oh man, good for time. Okay, I've got 2 more slides. We're going to make it. A couple more interceptors I will talk about. If you're building an application, a server application especially, you're going to want to worry about security, of course. You really can't do FHIR without doing health data, and you can't do health data without security. Those things all go together naturally. How do you do security in HAPI-FHIR? So first off, we do not do authentication in HAPI-FHIR. That doesn't mean you can't authenticate your users, of course. It just means that we do not provide an authentication framework because there's a million of them out there. They're all really good. There's no sense us reinventing the wheel. So, for example, there is Red Hat's, oh God, what is Red Hat's product called? Keycloak is a lovely, lovely authentication authorization server. We integrate well with it, but we're not providing you the actual authentication layer because there would be no point in us doing that. On the other hand, authorizing your users, we absolutely provide support for. There's two really neat interceptors, the authorization interceptor and the consent interceptor. They can be used for things like setting rules that this user should only be able to access data that belongs to James the patient. Maybe you're doing patient APIs. In that case, you want rules about he can only see his own data. That would be a rule you could really simply implement using the authorization interceptor. So that would be a way of doing that. The consent interceptor is kind of neat. It allows you to enforce consent directives. If we had more time, we'd get into all the nuances of what consent directives actually mean. But let's say here, if you've got rules that specific data types can't cross state lines, or you've got an individual directive that James doesn't want to allow his spouse to look at his records. Those are the types of rules that you could put in and enforce with a consent interceptor. We also often see people using things like the questionnaire and questionnaire response resources as a mechanism for capturing consent. That's kind of neat. We also see a lot of custom interceptors to do consent. And finally, a brand new thing in our most recent release that was only put out about 2 weeks ago. So HAPI-FHIR 6.6 came out 2 weeks ago, and it finally added an item to the very last box here, which is audit. Previously, we said not yet in HAPI-FHIR, but we finally got an audit interceptor as well. And this kind of a funny name, the BALP audit capture interceptor. If you're not familiar with BALP, it's the basic audit log framework, which is a really lovely implementation guide that came out of IHE for generating audit records. So that's supported as well now. Last thing I'm going to talk about is validation. This is our final topic for the day. Validation is the other topic. I'll say anyone who's using HAPI-FHIR, there's a pretty good chance that they're doing server stuff. The other thing that there's a pretty good chance they're doing is validation. So we always got to cover that one as well. I'll say there's two validation frameworks in HAPI-FHIR. They're both important. They're both useful. One is the parser error handler. The parser error handler is a mechanism that allows you to sort of really, really lightweight, like it adds no performance overhead. And all it does is catch basic syntactic issues, structural issues. So, if there's elements that don't make sense, like if I've got a foo element in my patient resource that doesn't exist, the parser error handler will catch that. If I've got multiple values in an element that's only supposed to have one value, the parser error handler will catch that. So that's sort of basic structural validation. That's the parser error handler. The other thing is just the validator framework, and that does semantic validation. Semantic validation, what we mean by that is we are checking individual resource instances against FHIR profiles. Generally, in that case, we're talking implementation guides. It doesn't have to be an IG, but that's usually how this works. This is a much more robust sort of set of validations. We get into all the actual semantic rules that are encoded within an implementation guide, but it also comes with a bunch more overhead. Checking a resource against all of the different value sets and all of the different invariants and all of that does come with a performance cost as well. It's always important to realize that. And ultimately, you always have to make a decision when you're adding validation. How robust do I want to be? How strict do I want to be? And how much performance overhead am I willing to tolerate? And the answers to those questions will sort of help guide you. Maybe you use parser error handler in production and you use both of them in development where you're sort of a little bit more lenient, or maybe you want to be really strict in production and you use both there too. I can't tell you which of those is the right thing to do because of course that's very project dependent, but we've seen people all over the map with those things. So there we go. Last thing I'll say, we do have a public test server up at hapifhir.org. Do feel free to check it out. It is a sort of a test bed for all of our features. It's kind of a neat thing to play with, and we keep it up pretty much all the time. It does crash once in a while when somebody finds a way of crashing it, but it's mostly available. And that's it. Thank you, everybody.
So thanks, James. So we will take first the question from the room, and then we will check the online question. I think best is people would ask, and I think you will repeat because we are not.
Yeah, we can definitely do that. Any questions? Okay, so the question is around performance. How many resources can you store? What's the throughput like? What do you do about timeouts? That type of thing. So I guess we got to break that into two sections. There's JPA server and then there's everything else. Because of course, if you're dealing with a plain server or a client or anything else like that, effectively, in almost any of those cases, HAPI is not the bottleneck. Like if you're using a plain server, chances are it's your storage layer that's going to be the bottleneck. And you can always horizontally scale there by just adding more compute power to your plain server. It's fairly easy to scale that up. I'm guessing you're probably talking about the JPA server, though. That's typically where people are wondering when they're talking about performance. In terms of how much data can you get into one of these repositories, certainly I have seen people in the multiple billions of resources range. I've seen it actually a number of times with HAPI-FHIR. I will say we see it more commonly with our commercial customers. I'm not here to talk about Smile CDR, but that's our commercial repository. It is the exact same platform. And we found often when people get up to that scale, they sort of start talking to us about commercial support, and that ends up being the way they go. But not everybody does. Lots of people are using the open source library at that sort of big scale. It's not trivial to do. It does require typically spending some time tuning indexes on your server, and any database is always going to take some time sort of to manage it. The DBAs they're always busy. So that's a thing you got to do. You were talking about query timeouts. I will say if you're seeing query timeouts, probably the most important thing I can stress is be on a very recent version of HAPI-FHIR. We have been on a program over the last probably 6 releases, and we're still 2 releases away from completing it. So we're going to be at this for at least another 6 months of completely rewriting all of our database indexes to support bigger queries at better scale. If you're seeing database timeouts today, I would absolutely recommend get yourself up to the latest version of HAPI-FHIR. You will see significant improvements there. If you're not, post about it in our mailing list. We do try to be pretty responsive to that. And we've optimized for lots of use cases. There's always some we don't know about yet. So we are always trying to work better for even more use cases in the library. Thank you for that. Yes. Right. Okay. So the question is, how does the authorization interceptor actually work? The example given, which is a really good one, is, I'm probably authenticating with OAuth tokens. If we're doing Smart on FHIR, for example, we're probably receiving requests that come with a bearer token. And we want to make authorization decisions based on that bearer token. I'm going to give the simple example. A really common thing, certainly especially in the US these days, is consumer patient-facing APIs. Like lots of people are building those. Lots of people do this with HAPI-FHIR, and the authorization interceptor is very well suited to that specific task. The way this works is, I have in the longer version of this deck, I've actually got a nice slide that shows you an example, but I don't have it handy. So the way this works is you create a class that extends authorization interceptor. So you extend that class, and then you actually just have to implement one method in there. And that in that one method, you are going to receive a copy of the HTTP servlet request. And that's the class that has all the incoming headers and stuff like that. You'll use that header, you'll look at the headers, find the bearer token, and validate that bearer token with whatever your identity server is. You'll talk to Keycloak or whatever it is you're doing there. Make sure that the token is valid. And if you're doing these patient-facing APIs, what you're going to do there is figure out, okay, this token belongs to a patient, and that patient is corresponding to the resource ID patient/123. From there, and this is the part that it's so much neater seeing it. And I will say, go look at our documentation for authorization interceptor. There's great examples in there, but what you're going to do is you use this thing called rule builder, and it'll allow you to basically declare exactly what the user should see. So you can say rule builder.build.allow resources of type in compartment patient/123. And then you say done, and that's it. And you've written effectively one line of code, maybe 2-3 lines of code in your authorization interceptor. And the authorization interceptor, all you've done is declare that this user should only see data that belongs to patient 123. So that's either that patient resource itself, or maybe observations, claims, things like that, where they are the subject. And the server takes care of the rest. It handles blocking requests that aren't appropriate, allowing ones that are, all that good stuff. So it is designed to be fairly simple to take care of. Sure. I think we probably have time for one more, but there we go.
There around that integration, and how do you see that roadmap panning out? Things like, running logic in there and $sign plot.
Oh, I love it. Okay, so the question is about the CQF ruler and what we're doing to integrate that better into HAPI. For anyone who's not familiar with CQF ruler, that is an open source implementation of CQL execution. And if you don't know what that means, there's loads of good talks coming in the next couple of days about that. For anyone who doesn't know, Alphora, who are the team who built the CQF ruler, they joined us at Smile maybe somewhere around a year ago anyway. One of the things we've decided collectively is that we're going to merge those two code bases together. So the CQF ruler, like, it's not going away by any means, but its actual project probably will, because we're going to bring all of that code right into HAPI-FHIR's core repository. And the reason we're doing that is sort of to enable tighter integration. Like, we really, really believe in CQL as an execution technology. And I think one of the challenges with the frameworks today is they struggle to scale. I mean, there's sort of clunky interfaces between the two. We're sort of betting that this sort of tighter coupling between the two of us will allow for hopefully better scalability there. So, I mean, for what it's worth, certainly we absolutely intend to continue supporting CQF ruler. I'm hoping the experience is going to get a whole lot more integrated in the coming years. And I think we're at time.
So we have 3 more minutes.
Oh, perfect.
There's one question, because I think one was really answered. So does built-in logging interceptor provide details like request URL being made and time and so whatsoever?
I love it. Okay, so the question is the built-in audit logging interceptor, does it provide details around the request and all of that? So another one that in a longer version of this, we go into lots of gory details. The basic idea is BALP specifies an audit event that for every resource or every request, actually every operation, whether it's a read or a write or a search or whatever, it sort of highlights, it will include in the audit event the URL that was used, the verb that was used, the client that was used, the user who made the request, the subject, the target of the request, all that good stuff. The interceptor will include all of that stuff in an audit event and will send it to an arbitrary sync. And the sync is something you define, like it can turn around and put it back in the same repository. It can send it by HTTP out to a third-party server. Lots of good stuff there. Much like the authorization interceptor, you have to write a bit of code to use it. And the reason for that is entirely around the same sort of principle that we don't do authentication. So we don't know about the user in HAPI-FHIR. So effectively, you've got to implement a couple of methods to use BALP where you tell the interceptor, this is the name of the user, this is the name of the client. And with that done, the server takes it from there. It'll add all of that stuff into these audit event resources for you.
So thank you. I think we are on time. So again, so the slide would be available now. Recording will be available within 1 day. And I think thank you for joining, and hope you have another good session out there.
Thank you.